All right. Well, hopefully you picked up some really concrete tips, ways that you can improve your memory for contents of classes. Because, I mean, what's the point of taking a cognitive psychology class if you're not going to be able to apply it to your, improving your grade over time in classes? All right. Well, the next subject that I wanted to talk about is how memories are physically stored in memory. So here we have a picture of basically a neural network. And so you can see the cell body here in the front. This is the cell body of a neuron, and you can see its nucleus on the inside. And just to remind you guys of how neurons communicate, they have dendrites that reach out and make contact with neighboring cells. And also neighboring cells can make contact directly with the cell body of for example, this neuron. So information is collected from neighboring cells, and that information comes in the form of a chemical messenger, what we call a neurotransmitter. So the neighboring cell sends a message to, let's say, this cell that we're looking at here. And if the incoming information is strong enough that it exceeds this cell's threshold for responding, it'll cause this cell to have an action potential and pass the information down to any cells that it makes contact with through the terminal fibers of its axon. All of these little lighted areas are here to represent connections between neurons, what we call synapses. So your brain, your cerebral cortex in particular, is just this network of all of these interconnected neurons. We saw a lot of them in the last chapter when we talked about nodes and organizational structures and things like that. So you're a little bit familiar with the idea of how all of these neurons are connected with each other. When you form a memory, what you're doing is solidifying the connection between neurons. You are making, I called it a new synapse, because what happens is that a neuron that had been connected to another neuron and was just basically passing information along suddenly starts to recognize, I should only communicate with this neighbor when I'm talking about this one specific thing. I'm only going to fire and respond, send a message to my neighbor when it relates to grass, or when it relates to, class. Oh, I said things that rhymed. Or it relates to glass, or something that's crass. Sorry, I got stuck in a rhyming loop. Might as well go with it. So what happens in these synapses is that frequent communication between one neuron and another starts to get sanctified and solidified so that it will only communicate about certain topics. And that's what we mean by a memory. It will only communicate if it has a detail that it would like to contribute related to this topic. So I thought it would be fun for you to hear from this person who seems to have done better in neurophysiological psychology than I did, explaining long-term potentiation. Now, one thing I would like to correct, because apparently this person's a brain psychologist and not as much of a cognitive psychologist, is that we don't usually use the word learning to refer to what you're doing in classes. This we call memory. Learning as a whole, it has a very specific meaning in psychology, and it's really talking about a relatively permanent change in your behavior as a result of experience. And so when we talk about learning, we're usually talking about the kind of classical conditioning that Pavlov was able to do with dogs so that they could like drool when they heard the bell, or the kind of operant conditioning that Skinner did with rats and pigeons, where they learned to peck or to press a lever because they were going to get rewarded for that. So that's, we very specifically use the word learning. So what I would just like to change about this video, everything else I love about it, is I would like the word to say memory and long-term potentiation. And then it's perfect. All right, so I'm going to let you watch that video, and then we will come back afterwards and talk about physical storage of memory a little bit. You know what? Hold on, double check. I think there might, yeah, I'm going to, whoops, sorry. Oh. Okay, yeah, that's what we're going to do. And then when we come back, then we'll talk about retrieval processes.